We are talking about human eye defects and correction. Human eye is actually designed, it's a obviously an optical setup, and when light enters in the human eye, it is capable of forming a sensation. Light image translation is obviously by the brain. Human eye contains an organic converging lens. Light converges at one point. This is how human eye works. This is this is the lens of the eye. There is there is many other sections not required in physics. We just have to focus that human eye has a converging lens. This lens is capable of making image. For simplicity, we say the image form at retina. Precisely, image does not form on retina. It's only a type of a simplification. So in a normal eye, image get focused on retina. This is called perfect vision. This is a perfect vision when image forms on retina. Now you have to copy this screen. This is how a perfect eye is working. The rays are really meeting at the retina. This is a perfect vision case. This image is real, inverted, and diminished. But later our brain reverses it, so we are capable of watching in upright position. Normally, the image human eye is making is real but inverted. Our brain reverses it, and then that's why we can see everything straight. You have to copy this. Have you copied it?
Yes.
Now, this is a short-sighted person. Short-sighted means the person can see the close objects perfectly, but the person cannot visualize the distant objects. This guy has a problem in the human eye. This person's eye is actually having a bigger, thicker lens. It's capable of converging rays too early, and before the retina, the rays are converging. That is why the person can't really see the distant objects. This is called short-sighted. This is called short-sighted person. So give a side heading, short-sighted.
When an eye is too deep, that is when the distance between cornea and retina is too long, the rays propagating from a distant object do not meet on the retina, and the resulting image is again blurred. An identical problem occurs when the optical system is too high within an eye of the correct shape. In this case, the problem is known as myopia or short-sightedness. People affected by myopia perceive distant objects as blurred, and so have problems viewing a landscape or driving a car. However, the same people can observe close objects very clearly, and so they are called short or nearsighted. When an eye is too deep, that is when the distance between
Now, how they correct it? The person cannot drive, the person cannot look at the distant objects. They put a diverging lens in front of his eye, glasses. They tell him to wear glasses with a diverging lens. This is a diverging lens. What the lens will do, it will spread the rays. It will spread out the rays, and the rays then, as they are already spread out, they can be now focused on the retina. Initially, the lens was so strong or the eye was bigger that the rays are not meeting at the right position. So now you have to copy this screen.
Done.
This is called short-sighted problem. Now look at this person correction. We are putting a diverging lens to protect that guy, and now the person can view distant objects clearly. How come this is possible? Because How come this is possible? Because the lens, they have put a lens which is a diverging lens. It will spread out the rays, and then the lens, the eye lens, will converge it on the right position. That is why if you wear glasses, you know that doctors actually test your eye position and they give you a number. That number is actually a scale how much the rays should be spread out. So this is called the concept of short-sightedness correction. So now you have to copy this screen. I'm just coming, copy this screen. Now, this is a long-sighted guy. This person has a problem that he cannot see the close objects. This is a case when people are able to see distant objects clearly. The lens is weak or the eye is too short. So the rays actually cannot meet within the eye. They virtually go out and meet. This error is called long-sighted. Look, the rays are going out of the eye shell.
If the eye is too narrow, that is, when the distance between the cornea and the retina is too small, the rays propagating from a nearby object do not meet on the retina, and the resulting image is not sharp. An identical problem occurs when in an eye of the correct shape, the power of the optical system is too low. In this case, the problem is known as hypermetropia or long-sightedness. People who suffer from hypermetropia perceive nearby objects as blurred and therefore have problems in reading. When they want to read a book, they need to move the book to a distance of more than 25 centimeters away. However, these people can see distant objects and landscapes clearly. That is why we refer to them as long or far-sighted. If the eye is too narrow, that is, when the distance between the cornea and the
Now, how they correct it? Achha, first you copy this screen.
I've copied.
You have copied it?
Yeah.
Very good. Now, how they correct it? In order to correct the problem, they put a converging lens in front of human eye. They tell the person to wear glasses of a converging lens. This is a converging lens. So they that patient has to wear converging lens. Now converging lens will first compress the rays a bit. Then human eye lens converge it further. Ultimately, the rays are able to focus on the right position. You have to copy this correction.
Done.
So this is how we correct the image, and these are the figures. And we say nearsighted, far-sighted, and how we fix the errors. This is the fixation of the error. Now, least distance of distinct vision, where we can see a dot or something written clearly. This is the minimum distance we need. So we need to copy this. Least distance of distinct vision.
Done.
So this was the remaining small thing for lenses. We did that. You have to try to do the MCQ paper